Hello, everyone. Thank you for attending to this session. My name is Jaeyoung Lim, and I'm currently a PhD candidate at ETH Zurich in Switzerland. And today I'll talk about Ignition Gazebo, which is a new sort of version of Gazebo, integration into the PX4 simulation environment, specifically in the software-in-the-loop simulation, and how you can benefit from it. So a quick introduction to the PX4 simulation environment. Why do we actually care about simulation? PX4 uses simulation quite extensively. One of the most useful features is that you can actually demonstrate behaviors of the vehicle, whether you are doing development on top of a vehicle or you are updating to a new version of your flight control software. Without actually going out and risking your vehicle, you can actually try a new version, the flight control software in a safe and sterile environment. Also, for developers, when you're developing your flight control software, you don't actually need to go out and fly. You can iterate very fast by simulating everything in the simulation environment, especially if you're developing risky features. You can test these features quite safely. One of the most important use cases of simulation in PX4 is testing. For example, if you make a pull request in the PX4 Autopilot project, the continuous integration and testing system will start software-in-the-loop sessions with all kinds of vehicle targets and all features, so that there are no unexpected regressions being introduced in by the pull request. So as you can see, this is one of the examples where the software-in-the-loop simulation is actually run faster than real time, of course, in headlessly, and this is being tested automatically with MAV SDK. This is also important because this actually unloads flight testing requirements, so that people do not actually need to test for all vehicle targets, fly a real vehicle. The PX4 simulation environment supports various different simulators, Gazebo being the most standard and widely used simulator developed by OSRF, but also one of the popular simulation is JMAVSim, also supporting simulation in hardware use cases, which is popular because it's very simple and very lightweight to run. Recently, PX4 also integrated into JSP-Sim, which is a high-fidelity flight dynamics simulator, so that you can simulate complex vehicle dynamics, such as aerodynamic effects for fixed-wing or VTOL vehicles. Also, AirSim from Microsoft also provides support for PX4 software-in-the-loop and hardware-in-the-loop environments, which actually uses the Unreal game engine, providing photorealistic environments in case you need for vision-based applications. Today, we'll talk about the PX4 simulation environment being integrated into Ignition Gazebo, which is a new kind of gazebo from one of the most popular and successful simulators in the robotics community, which provides the ability to plug in more advanced rendering engines. You can also do distributed simulations, and there has been quite some development with more advanced sensor plugins. So you can find the repository at the link below. And currently, PX4 works with Ignition Edifice, but recently there has been Ignition Fortress announced, and PX4 plans to integrate into that too. So you can, on the right, you can see an example of the Ignition Gazebo environment being run through the Ignition Gazebo. What people get sometimes confused is what Ignition Gazebo is, because there's also these different packages such as Ignition Transport or Ignition Physics being used. And this is because the Ignition is a project where it includes the essentials for building a robotics simulator. And Ignition Gazebo is using this infrastructure to simulate the world. Ignition Gazebo also hosts a model database called Ignition Fuel, which includes various vehicles, robots, and also objects, 3D objects, so that you can benefit from this vast database to develop depending on your use case. So here's a small sneak peek of the software-in-the-loop simulation running with Ignition Gazebo. On the left, you see the screen of the Ignition Gazebo, and on the right, you see the screen from the Q ground control station. What is nice about the PX4 software-in-the-loop simulation is that you are actually running the actual flight control software, since PX4 is POSIX compliant. And that the Q ground control actually does not know whether you are flying a real vehicle or a simulated vehicle. So you can test your end-to-end workflow without having additional interfaces just for the simulation. So you can, as you can see, use the same interface as you fly the real vehicle in Q ground control and simulate the mission and various fail-safe cases. So how does this work? The PX4 flight stack and simulation is communicating through the Mavlink protocol, which is also used to communicate between vehicles or to the ground station. And the flight stack and the simulation is running on a lockstep, meaning that when the simulation progresses one step, the flight stack progresses one step, sends the actuator controls. Then the simulation progresses one step, simulating the dynamics and giving back the sensor data to the flight stack through the Hill sensor message. And this way, the flight control software and the simulation are in sync, no matter how your system is powerful. So the simulator or the flight stack doesn't lag between each other. This is the Ignition Gazebo environment is already merged in the PX4 Autopilot project. You can simply clone the Autopilot project and run make PX4 SITL ignition, and you can follow the documentation in the PX4 document simulation section to get started. If you're interested in running the simulation without running the graphical user interface, you can also do so by adding headless in front of the command. So the Ignition Gazebo has a Gazebo Mavlink interface integrated, so that this provides a communication channel to the flight stack through Mavlink, and this talks to different plugins inside Ignition Gazebo that needs to talk to work with the flight controller, such as the motor models or actuators or sensors. And this information goes to the simulator module inside PX4, which talks to also various modules inside PX4 through the UART message. What is different between Ignition Gazebo and Gazebo? I guess a lot of people will who are interested in Ignition Gazebo will already be using Gazebo and are curious how they can migrate to Ignition Gazebo. So the overall structure is quite similar, although in Ignition Gazebo, you have a pre-update state and a post-update state compared to the classical Gazebo, where you can actually take actions before and after the simulation step. And this is quite useful if you are simulating some kind of a very if you have impacts in your system, or if it is unclear what you're trying to simulate is, or if you want to check between the step execution of the simulation step. You also have much more control over the simulation step and the components inside the sim. So you have now the entity component manager, where you have access to various entities inside the sim directly. And yes, and you have the configure method, which is which you configure the plugin when the simulation gets loaded, and when the simulation is being executed, the pre-update and post-update state will get executed. One of the very new features in Ignition Gazebo would be, or one of the exciting features for me would be levels. So what this does is, if you're simulating a large environment or a complex environment with classical Gazebo, you had to load the whole environment in the simulation, which required you to have a powerful system. With Ignition Gazebo, you now have levels, and so the robot, or performers in this case, can move between levels. Levels can also overlap with each other. And depending on which level the robot is included in, the environment and objects get dynamically spawned and removed. And this makes your simulating very large environments with a limited computational budget much more handy. And also, in case you are simulating in the cloud, it relaxes your computational requirements a lot. So to show you one of these things working, so this is the tunnel environment in Ignition Gazebo. You can also see the Ignition Gazebo shows much more nicer rendering compared to the classical Gazebo. And what is happening here is that while the vehicle is traversing the tunnel, since it's a very big tunnel, rather than simulating the whole environment at once, the vehicle is moving through levels. So the parts of the tunnel are being dynamically spawned or removed depending on where the vehicle is. And you can also see the video stream on the bottom coming from the camera mounted on the vehicle. So in a moment, you'll see a view of the path we have been through, and you'll see that the tunnels we have been through have actually disappeared. So thank you for listening. I am quite excited to be working on this new simulator, and hopefully through the Dev Summit that we can have many more contributors and more exciting functionalities coming. If you have any questions, I can answer them. You can put it on the Q&A or on the chat. So the question is, will there be support for HIDL simulations in the future? Yes, definitely. The API itself already supports HIDL simulation. Most of the simulations share sort of common library that also supports HIDL. And this will be definitely something that we would like to support in the near future. Does the simulator next question is, does the simulator support VTOL fixed wing model? The answer is not yet. So in classical Gazebo, PX4 had sort of a separate dynamics plugin to simulate lift and drag dynamics or aerodynamics that is more relevant for drones, and we would need to integrate this into Ignition Gazebo. So another question would be that, can we use Ignition Transport to simulate the network communication between drones? Ignition Transport is a messaging system designed to be more or less for components inside the simulation. So the answer is, of course, you could, but this wouldn't be realistic if you plan to use Ignition Transport on a real vehicle. So I would say actually that the software in the loop simulations already talk Mavlink, which is actually what real vehicles use for simulation. So the communication itself is actually already being simulated by talking to Q-ground control. And this is also how vehicles can talk to each other on the real vehicle. Next question is, would you consider Ignition Gazebo mature as reliably working as normal Gazebo? I guess it depends on what you're looking for. So I would say it's mature enough that we can obviously run PX4 simulations on it. And there are quite some exciting features coming. Of course, it is not an environment like the classical Gazebo where a lot of people are already using it. But I would say it's already, it's also not the first version. Edifice is already, there has been quite, it's one of the more stable releases, I would say. So yes, I think it's good enough for most people. Next question is, when do you think there will be support for a UGV? I guess that depends on how much people contribute to this project. So I'm quite excited to see people contributing, what kind of use cases people have for this simulator, and also PX4 in general. So please feel free to contribute. Comparisons between PX4 and rotors with Gazebo. What would you recommend, since your lab developed rotors, if I remember? Yes, so I'm glad to hear that you're using rotors. It actually was developed from our lab quite some years ago. So the PX4 SITL Gazebo, the classical Gazebo plugin of PX4, is actually based on the rotor simulator. However, the difference would be that rotors is a simulator to work in the ROS environment, so it's ROS dependent. And SITL Gazebo, PX4 SITL Gazebo is not ROS dependent, so it just works with Gazebo. You don't need to run it in ROS, and it uses Mavlink as the primary communication channel to the flight stack. You can optionally run it in ROS. It's also a Catkin package, but that would be the difference. So yeah, so yes, rotors also is not a flight stack project. It doesn't matter which kind of flight stack you're using. So I guess it depends more on what you're looking for. And the next question would be, is the motor dynamics model still based on the rotors plugin, or is it a new implementation? So I assume this is not Ignition Gazebo specific question. So the motor dynamics model has been based on the rotors plugin initially from quite some years ago, but there has been a lot, the physics itself is quite different. For example, in the PX4 SITL environment, the motor model considers wind, so you can simulate what kind of effects wind has to your vehicle dynamics in PX4, which is not, as far as I know, present in rotors. So yes, so it's a derived implementation, not a new implementation. There's also a question in the chat. How does the rotor ROS interface differ from standard Gazebo? So these are not substitutes. The ROS interface, so Gazebo has a ROS interface, so you can use Gazebo with ROS. Sorry, so maybe I misunderstood the question. So how does the ROS interface differ from the standard Gazebo ROS interface, if I understand correctly? I think Ignition Gazebo is designed to be better integrated into ROS2. So personally, I have not been using ROS2 with Ignition Gazebo yet, but it's something that I'm quite excited to try out. Are there any more questions? So one of the questions I get a lot regarding Ignition Gazebo is that why would you migrate to Ignition Gazebo when you're perfectly happy with Gazebo? And my answer would be that as far as I know, I think it's developed by a more or less similar team from OSRF, the new Ignition Gazebo. And I have a feeling that the Ignition Gazebo is sort of built on top of all the insights or experiences that the Gazebo team has learned. And from even if it's in the sort of early stages of the project, there has been quite some exciting features coming in. You can also see from the demo that it actually looks much nicer, and also with these kinds of levels, you can now really start doing look into more advanced capabilities, simulating very large environments and realistic mission scenarios that was either too expensive or hard to do with the classical Gazebo. Will PX4 be an organization for GSOC 2022? Honestly, I would not know the answer for this question, but I would presume that you'll have enough people to discuss this during the summit. If you have any more questions, please feel free to ask. And the PX4 simulation environment has always been from the community the most exciting contributions, because it's very hard to know all the different use cases of the simulation or applications, and the most exciting or the most impressive ones come from actually unique use cases from the community. So please feel free to contribute, or even just if you have any questions, don't be afraid to ask questions inside the repo or the community. We're very happy to listen to what is not working for you, or what the current simulation is doing poorly. Does PX4 SITL support geometric control of drones? The software in the loop simulation is merely an environment to test and simulate basically your vehicle and flight control software. So it does not necessarily support specific control algorithms. This would be a job of the flight stack or the end user's application. What is the maximum number of drones we can simulate simultaneously in a gazebo simulation? Is it that we can simulate more numbers in Ignition? So in Ignition, it doesn't actually matter which simulation environment you are. You can simulate as much drones as you want. The only thing you need to be careful is that since the vehicles use Mavlink, there's the SysID number is limited to 255. If you have a ground station, maybe a few less. So so the answer would be around the 255 numbers would work out of the box. Personally, I have tested over 100 vehicles on my desktop without much problems. So that would just work. But yeah, as long as you can handle sort of the Mavlink networking problem with Q ground control, you can. It doesn't matter actually how many vehicles you can simulate. It's more of a problem that QGC would not work with more than 255 vehicles. And if you have your own ground station or a way to handle that, you can simulate more. Does Ignition Gazebo support GPU? And the normal Gazebo, it seems there's a CPU bottleneck for multi-agent simulation. To be honest, I would not know what you're talking about with the CPU bottleneck. But yeah, as long as the simulator is capable of simulating the sort of number of vehicle dynamics, it should be able to simulate PX4. So thank you, I think the session is planned to end now. Thank you everyone for attending the session. I'm very honored to be here. I'm happy to be part of the awesome community, and hopefully I'll see you around during the summit.